Welcome everyone to the Package Manager workshops. So this is where we unlock the power of open source. So first things first, the outline. So what are package managers? Next is parts of a package.json file or the project.toml file, the scripts, dependencies, the dependencies in it, and also let's talk about a little bit about log files. And to end the session, we're going to have a demo wherein we're going to be demonstrating using React and then creating a simple Google Maps using a library that we can install. Alright, so first things first, package managers. So package managers are developer tools that allows developers access to libraries in the open source world. So usual system is that you have your device that has a package manager. It looks when you type, let's say, npm install a particular dependency, it looks for that dependency in a specific repository. That repository depends on what package manager you're using. So if you're using npm or yarn, you're going to be using the node package manager repository. You might have seen that in one of the website. I think it's called npmjs.org or something, or .com. But anyways, it gets the package from there and goes back to the user. So there's a couple of package managers that are related to web development. Mainly they are, firstly, the JavaScript, which one you have the npm, where you can run npm install. You also have the yarn install. And next is for Python, we have pip. So some of you might are familiar with pip, and then I think the file is called requirements.txt. And then we also have poetry, which we'll talk about in a second. And just to let you know is that most libraries out there, it kind of looks like this. So you see all your modern digital infrastructure, and then you have some random project out there wherein every other modern digital infrastructure depends upon this one. So yeah, so it's a project some random person in Nebraska has been thanklessly maintaining since 2003. So something to be aware is that when this dependency fails, all other dependencies on top may fail. That's the reason why we have log file, which we'll talk about in a second. So furthermore, I'd like to say is that we have come to an age where our code contains more code written by other developers than our own code. And as you might have seen, probably, let's say, for example, you're creating a React application, you're going to contain React libraries, and then those React libraries are also going to contain some other dependencies. And yeah, I think that's just how the modern development goes in, wherein you have abstraction and abstraction as far. We went back to from electrical engineering, where we have zeros and ones on circuit boards, then we have assemblies, and then we have languages like C, then we have interpreters, JavaScript, and all sorts of things. And then further to JavaScript and also Python is the fact that you have libraries that are sitting on top of it. Yeah, so let me just give you a quick example of Express. So for the people that don't know here, Express is a library that helps in creating server applications in JavaScript. So this is what Express looks like, and as you can see, there's a lot of dependencies all around it. You can take a look at that in this website. But essentially, if you take a look at this, there are 53 nodes around Express. So that's just some indication of how many dependencies are you will get, or some dependencies that you will get if you include Express in your application, for example. Here's another example, Material UI. So Material UI has around 37 nodes, 75 links. So these are dependencies on top of dependencies. Okay. Next thing, how to install package managers. So depending on what package manager that you're going to use, you're going to install it differently. For npm, it comes pre-installed with Node.js. For yarn, you have to install it from this one. Pip comes pre-installed when you install Python, and poetry comes you have to install it from this website. Just something to point out for the people in the room. What's the difference between npm and yarn? Well, the only difference that I could tell you about it is that yarn is better. And also with pip, actually I can explain more why poetry is better than pip. So the thing with yarn is that if you had further experience with how yarn works, is that it calculates some portions of subdependency, which essentially makes it like a better package manager. And you could even try this for yourself. Is that you would notice that yarn yarn just works, and also you might, if you do some performance metrics, majority of the time yarn would be faster. That's the reason why in the food bank and the waste project, at least for anything that's related to JavaScript package management, we're going to be using yarn. And I'm going to show you the syntax later on. Next is with pip and poetry. So as you might have seen, or if you have any experience with pip, whenever you do pip install, it doesn't really record the dependency in any file. With npm and yarn, it records it in a file called package.json. We'll take a look at that in a second with the different parts of it. But the problem with pip is that it doesn't track your dependency as much unless you specify it to, and you have to do it manually to update it. Unlike poetry, poetry kind of works similar to yarn and npm. Okay, next one. So let's take a look at a package.json file or a PyProject YAML file. So actually, let's just go to this website in a second. Yep. So this is the Coders for Causes food bank project. This is what the package JSON looks like. To give you a quick summary of what a package JSON has, it has scripts, the dependencies or libraries that you use, the deb dependencies, and a couple of other bits, the meta information. This is similar as well for the other project, DataPane. DataPane is a library for dashboarding in Python. So this is what it looks like. You have your meta information, you have your dependencies, you have your deb dependencies, scripts, and other bits. Alright, let's take a look at that in more detail. Firstly, the package header meta information. So it contains some meta information about the project, and it's usually used for publication, especially if you want to publish your specific library or package that you've created in the internet. So FoodBank doesn't really have that much information because we didn't design the package.json file to be a library. So it just has some basic information. But let's take a look at DataPane, for example. DataPane is a library that you use. So it's going to have information such as name, version, description, author, license, readme, homepage, repository, and documentation, and all sorts of things. The reason for this one is that this meta information appears whenever you publish a library. So let's take a look at something, for example. Let's take a look at React npm.js. So this is what some bits and portions of the meta information has. The version numbers, the keywords, and also some other bits. So if you take a look at the Facebook React, there's probably a package.json file there. Yep. That will match those certain details. Somewhere here. Huh. Strange. But yeah. I think it's somewhere there. Packages. Yeah, I'm not sure. But anyways, that's the usual scenario wherein those details are actually published in the package managers or the repository that you're publishing it. The one for Python is PyPy. So this is usually where your Python packages will come in. So whenever you do pip install or poetry install, it will install it from here. Let's take a look at NumPy, for example. Yep, this is what it looks like. Some descriptions, GitHub repositories, and links, and also maintainers. Yep, that's the bit about that. Next, hang on a sec. Yep. Next, dependencies. This is probably the most important bit of your package.json file or your poetry.toml file, pyproject.toml file. To be able to install the group of dependencies in the package.json file, you have to write yarn install or npm install. For Python, you're going to have to write poetry install. So as you can see, the syntax does not differ as much. It's usually a convention that you're going to have something similar. For the people that have used Linux before, you might have seen this before, wherein you write apt-get, then install the package that you want. But just a little bit of a difference. Apt-get is for the installation of packages for your operating system and also applications that you're going to use. This particular installation is usually on what's called local dependencies, which is it's local to a particular project that you're working on, which means that if I run food bank, for example, I do npm install, I'll be installing React at version 17.0.1. But maybe in another project, I did a yarn install. It's going to do it might install a different version. So let me give you another example of that one. So I have a demo code here. This is from Create React App. This node modules will contain all the installed dependencies. So sub-dependencies and dependencies. As you can see, it's really quite a lot. And I'll explain to you that in a second. Just make sure that, just the important thing to note here is that every time I do an npm or yarn install, it's going to create this folder called node modules. And this node modules is specific to this particular project. So if I move to another project, I do a installation, I could have a different version of it. Something to point out here as well is the git ignore. So relating back to one of our workshop, the practical software engineering workshop, is that we use Git to version control the important files out there, the actual change that we make to the project. And whenever we install dependencies, we usually don't put that in the version control system because that version is dictated by the package.json file. So there's no point putting this in the repository simply because the node modules is a very, very big file. So I'm not sure if I could open it here and I could show you how big the file really is. So open. That's climbing a second. But while that's counting, let's go back to git ignore. So the only thing we really want to put in the git ignore files are the ones that truly matters, which are the changes for the source files. The things that we put in the git ignores are the things that will be ignored by Git. So let's say, for example, we're ignoring changes that happens at node modules. Let's just go back to here in a second. Take a look at this. The size of a node module is 100 megabytes. And if you think about it, if I put this changes in the GitHub repository, it's gonna have a very high latency, especially if somebody tries to get a new a copy of the main source code. So this one doesn't really matter as much because you can install it. So let's just quickly compare that to the rest of the files. So as you can see, the rest of the source code is only has like around 526 kilobytes. Node module is like around 180. So yeah, be mindful of that. that you should not be putting your dependencies in a GitHub repository. Use git ignore to ignore that change, and also just keep track of the dependencies in the package.json file. This works similarly to Python as well. Okay, now going back, to be able to add dependencies here, you just type yarn add and then the dependency name. For example, I want to add d3js wrapper or something like that. I do yarn add d3js wrapper or something. The name of the dependency. Similar to this one. Poetry as well. Let's say I want to add poetry add, what's a library name? I think requests. There's a Python library for requests, HTTP requests. So that's an example. Okay, next. Deb dependencies. So the difference between deb dependencies and dependencies is that deb dependencies are libraries that are used in the project on the development environments. And examples of that are usually the linter files or the tester files. Let's take a look at FoodBank, for example. It has deb dependencies on the storybook component. It has deb dependencies on the libraries for jest and also some ESLint configurations. The reason why we put it as a deb dependencies is because if you think about it, if we install a particular project at a production environment, it doesn't actually need testers library. It also doesn't need linters. So as much as possible, we want to minimize the size of the production environment if it's not going to be using other dependencies, because it can cause some conflict with sub-dependencies. So this is the same for the data pane. A couple of things that they had is that they had PyTest, they had Jupyter Lab, and all other PyTest plugins right here. To add a deb dependency, this is the syntax. You have to do yarn add -d, and then dependency name, and then you could also do yarn add --deb dependency, and then your dependency name. Similarly to poetry, it's a poetry add deb dependency and then dependency. So as you can see, in terms of difference, you only added like the deb dependency flag. Something to keep in mind of. Next one is probably one of the important parts of the package.json file. It's actually much more important in JavaScript rather than on Pythons. So package scripts are aliases of commands to run using the modules in the dependencies. And I think in the projects that you've done, I'm sure that you've been advised to run to type this command yarn start or npm run start for your React project. So what that does in the background is actually it does this. It does yarn build css, which it runs this particular command, and then it runs this command react scripts start. The reason why I said to run using the modules in the dependency is because if you type just react script start, it won't actually, it will have an error majority of the time. It's gonna say react scripts command not found. So it will only work if you type npm install -g, but typically you don't want to install a library or dependency for your entire system, because what ends up happening is that what if another project wants a different version of that package? So that's the reason why we have local packages for that. Similarly for poetry, it's poetry run then the script name. So poetry run data pane, it will run this command. Okay, now let's talk about log files. But before we do that, does anybody have questions about the previous slides? Okay. Is it clear? Okay. Anyways, if you have any questions, just feel free to ask later. Okay, now let's talk about log files. So log files, the purpose of a log file, actually before we go to that one problem that we might have in, let's say for example, this one, the express, is that what if a subdependency change a version? Let's say for example, this one, I'm not sure if it's readable. Actually, let's take a look at this one for example. There's a library called send, and it's at version 0.17.1. What if that changes, and if it changes, it actually has an extent, an impact towards our application. It might impact our application depending on how you use it. So from the last time you run your application and it worked, whenever you do npm install again, it might not work because the subdependency version changed. I'll give you another example for the syntax. Let's take a look at this again. So pandas is equal to a caret symbol 1.0.1. What the caret symbol means is that it will upgrade to any version that is more than 1.0.1 but is not more than the major version. What it means is that to give some summary about versioning is that we usually increase the major version, this first number, higher if it's not cross-compatible. Meaning that if a library increases its number from pandas 1.0.1 to pandas 2.0.0, it's almost guaranteed that every application that uses pandas will break. That's why they have what's called a migration strategy. So usually you lock the dependency by a caret symbol to only say that your library will only upgrade whenever this two numbers changes and not this major version. Okay, now let's go back to the package.lock.json file. So here's an example of a package.json lock file for the WAIS client project. So it's going to have Babel things, some all sorts of dependencies. As you might have seen is that I think we only have like one Babel dependency for the waste project, but you're gonna see that there's a lot of other dependencies. Like it never runs out. Like around 9,000 lines. So this is somewhat similar to if you take a look at the node models. We have so many dependencies out there, but we actually only said that these are the only dependencies that we're gonna use. So a subdependency is basically a dependency of your dependencies. So like what I said, React might have more subdependencies, even though you only say your app is dependent by React. By transitive property, your application is dependent on React, but also the subdependencies of React. So going back, so what's the purpose of a lock file? So it locks the dependencies and subdependency versions of your application the last time it installed correctly. Keyword installed correctly. So whenever you're installing things, you might have seen that the package.lock.json file changes, or the yarn.-lock, or poetry.lock will change. So that's the case with this one. Every time we do an installation, this will change, or some bits of it. Also, another comment right here, auto-generate that file. Do not edit this file. Most production system will actually not install from the package.json file. The production system will most of the time install from the yarn.lock file, because we don't want chances where in the production system, when it's installed it from something that we know that it was working from a dependency point of view, no longer works, then that's a little bit faulty. Okay. Now let's go to the next slide. Installing globally. I think I've mentioned it in a couple of slides before, but whenever installing packages, it is recommended to install it for a specific project. The only thing you really should install globally are the CLI tools. And even then, you have to use npx majority of the time. Here's an example. You might want to use a Firebase tools. So you're going to install npm install and the global dependency, Firebase tools. So next time you're going to be able to use Firebase command, you're going to say Firebase init or Firebase, yeah, all sorts of different commands. Okay, I guess now let's a demo. So going back to the React applications here, what if, what I want to do with my React, okay, firstly, I do a install. It's going to install my dependencies, going to put node modules. It only took like a second because it just checked and made sure that everything works. I type yarn start. If I do yarn start, it will basically execute the script. As you saw that, it executed the script. And then it will create us a development server, which we can access at this one, localhost 3000. While we're waiting for that one, let's say what I want to do is I want a React, but I want, Google Maps. Because, maps are cool. That's the reason. Alright, let's take a look at a couple of packages out there, npm.js. There's 2 of them. Let's take a look at what it's all about. There's also this one. So this one, according to this one, it said badge not found for this one. Looks like it's not maintained anymore. Last published 3 years ago. It might be inactive. So probably scratch that. We're not going to be using that. This one seems like it's a bit newer. Looks like it's a complete rewrite of the sadly maintained React Google Maps library, which is probably this library. This one was updated a month ago. But let's take a look at the GitHub repository. It has 885 stars. Let's take a look at this other one. Well, this one is looking a little bit promising. It has 5.3k stars. So, intuitively, we might just use this. So, let's use that. And this, the installation process is usually defined here. So it's called yarn add Google Maps React. So let's just do that. I think I might have to restart this this React app. So this is how I started with. Let's create a new component. Then let's create that, maybe let's just name it maps. Like the file name is called maps, map.js. And let's move this component into the source directory. Now while we're waiting for this one, let's start creating references. So we want to import the maps from one of the components, and then map.js. So what we want to this one, or if see, and this is the map component that we have, just making sure that it works. This is map. Then let's change this entire thing with just the maps. So now I've successfully installed it. Let's take a look at actually the package JSON file. So one thing that you might see, this one was added, version 2.1.10 with the caret symbol here, which means that it can upgrade to other versions. Take a look at the yarn lock as well. It also changed slightly. But just wanting to make sure that you know the purpose of the yarn lock file. Next thing, let's take a look at this one. So this is our development server loading. We added the Google Maps library. So let's just get that one. Yep. Yes.
Friends, your stream is loading, lagging.
Lagging. We missed a couple of things you said in the last 1 or 2 minutes.
Sorry about that one. Okay, let me just repeat that one. So as you can see here in the right terminal that I had, I was able to install the Google Maps React file. And then that Google Maps, by installation, it added a new version right here in the package.json file. Now, it also changed the yarn.log file at an extent. I don't know exactly what changed, but it doesn't really matter as much for me. But this is the important bits. This one, and because this thing exists here in the component that I had for maps, I can import that as a thing. So now let's take a look at our app. This is map. Yes. Now let's just replace that to our maps. So, like any developer, I don't exactly know how this package works, but it said getting started. So might as well just copy paste this one and also do a couple of things. Hopefully this works. So I have, a component here and it goes to that one. Yep. So now take a look at this. I have a Google Maps. I just have to put some API keys right there. But as you can see, fully interactive, I can do full screen. I could do zoom ins, and also basically any features that Google Map has. And it's just a couple of lines of code, and it's just a matter of using the power of open source, the code that was written by other people, so that we could use it in our code. And I don't think this is quite hard. You just have Google Maps React component over here. You have your some parameters, and usually those parameters you can cross-reference that to the main documentation. So this is the example that they had. Yes, I think that's the end of the demo. Just a couple of seconds. Import the library, install the library, import the library, then use the library. So in the project, you might have seen maybe you might want to do some React dropdowns. Some people have done it. You might also just use material UIs. But if you've seen some libraries out there that caught your attention and you want to use it, you might want to actually just research and also read the documentation. Because as I've said, we've already come to the age wherein our applications most of the time contains codes of other developers rather than our own code. So yeah, here's the examples that this thing is showing. It manages the notifications for you. As an example of a library. So yeah, this is the end of the workshop. Any questions?
I didn't know if there was like a generic name for a package.json or Py project.toml, perhaps like a configuration file.
What do you mean? There's so all the projects that you had in the for the winter projects, you're going to have a package.json file somewhere out there. So let me show you Waze, for example. So if you go to Waze, you go to client. The client uses Vue as the front end. So you're going to have a package.json file here, and you're going to have dependency about the Vue.
I meant more in a terminology way. Is there like a library or package manager agnostic way to refer to a package.json in English?
In English? I guess it's a file that contains all your dependencies or libraries that you want to use. I think that's the simpler way to explain it. Does that answer your question?
Sort of. I understand the concept of it, but I was just curious whether there was a term or a word in English. For instance, we can have in languages getters and setters. That's a term that I would consider language agnostic. You have getters and setters in Python, Java, etc.
Yeah, I think I would just say it's a actually more on it's like package uh, package version management file, because it is what it is, right? It's a package, and it controls the versions of the package that you had for a
I was
particular
asking
project.
this exact same yesterday. Yeah,
Yeah.
like a general name for these kind of files.
Yeah, you're actually correct about that one. I don't know any the generic name for that one, because like for example, if you
Yeah.
take a look at Python, it's called pyproject.toml. Any questions? Um, I think that's all for now. So I'm going to stop the recording now. So yeah, I think you guys can go if you're done.
Cool.